Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem. That is a word search 2. This is a hard type problem and we'll understand how you can solve this question easily. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we are given an m cross n board of characters and a list of strings words. We need to return all the words in the board. Like we need to return all the words that are there in the string string array and like which are there in our board as well. So it return all the words on the board, right? So each word must be constructed from letters of sequential adjacent cell. Like those should be the sequentially adjacent cell where adjacent cells are horizontally or vertically neighboring. Okay. The same letter may not be used more than once in a word. Okay. So that's what we need to go ahead with, and we need to understand how we can do that. So let's look at this example. I guess that would be much easier. So over here we have a board, fine, and if you look at the words list given to us, the words list is this, and the output comes up to be eat and oath. Okay, let's understand. First of all, we start from a position, then we move to the right, we find OA, like we are finding a match for the first case, so OA. Then we find T, that's moving down, okay, and then we find H, that's again moving down, right? So that's how we found our word. And even if you look at the next word, that's eat, that is found, is like E, then moving to the left, then moving to the left. So EAT is in this format, we find it. Now the thing is, if you look really carefully, you'll find something really interesting. The interesting part is, let's see, we are more or less going in all directions to find out if there's a match for the next case or not. Like just look at the words over here. Okay, let's think intuitively of what we can do. So we somehow need to find the word character by character because that is a character array given to us, fine? So if we need to find the word character and character, then we somehow need to traverse through this whole board given to us, right? The whole board we have. So we somehow need to go character by character. We somehow need to go in all four directions, finding if there's a match in the top, in the left, in the right, any direction if there's a match, right? So how we can go up about that, like how we can find that? So that's something you can think. Like we are more or less doing a backtracking, or not say backtracking directly, but rather say we are in a graph kind of manner or in a DFS kind of manner. Why at any instant, at any node, we are trying to find the left, top, left, bottom, and the right. We're trying to find whether we can move from this position to the left to find a further match. Where there's an R in the range, so we find a range and we try to move in four directions to find out if we can get A or not. Fine. So that's you can think. First of all, kind of a DFS approach. Okay, just we are trying to find out whether there's a match in the characters further or not. Now you may ask, like, how is it possible? Because there's a whole range. I mean, it's a whole string is there, and there's a character by character is going. So whether are we going to break it into a string character and then find to like going to find each of them or not? No, obviously not. That's a much feasible case because you find a R over here, and then you need to look for a R in all the like words given to us that's starting with R, and then you convert that into a character array. That's not a feasible way. That's not a way we should think of. Okay, so how we should do that? See, whenever we have a set of words we need to search in, fine. What should come in your mind is a concept of try. Okay, because that gives us the best opportunity to look for it. Let's understand what it is. What we'll do, we'll from and try directly. So we need to understand or we need to know what a concept of try is. So I'll explain it now. So what try is basically having say a character array of 26 length. Okay, so what this array stores each of the positions, like each of the positions like 26 characters are there. So wherever there is a start, okay, say first we come across the root, fine, in the try node. So each node will contain a this array with us. Okay. So what will happen? So in the root we have this node. Fine. We have this node, and in that whatever the first characters are there. Say first E is there, so we'll store E. We'll store that E is there. Fine. I'll tell you what we'll store there, but let's know that we'll mark that E is there. That's the first character. Fine. Then we'll mark like there's P is there. like there's O is there, so we mark it for O, then we mark it for P, right? Then there's R, okay? We mark it for R, okay? Say we mark it for R. So it's like E is there, it's like O is there, it's like P is there, fine? And another R is there. So this is the terms we find over here. So how it will help us, like in the next case, from E, we'll move for next character, that is A, okay? See, from E, we'll move to the next character, that is A. Now what will happen, if we're moving to the next character, that is A, that is, the next character is A, fine? So from E, we are moving to A, and from O, we are moving to A. Okay, not necessarily these are the same, but these are like two different characters. So we won't be moving to the same node, but it's like from A will be another node. Okay, from OA is there, so we're moving to that. So what will happen? We are just storing this in a format of like various strings to find out if there's a path. Say there's a hypothetical word like OA TH. Fine, if another word, and say there's another word that is OA T and then D. Fine. So what we'll do, these three are fine. So what will happen? So O, then A will be marked into the same, and from A we'll mark to another array, which will store our D, right? Like, or which is to a T, that is T for this case. And from T, there will be two different bifurcations. One will store the D, okay, another will store our H. So what will happen is like we have a node that once we're going down the tree in any of the path, we know that that's a word present for us, fine? Because like whatever the characters are marked in the root, we know directly that this is the starting points. Okay, so we don't need to look for everything, and there cannot be more than 26 starting points, right? So we are just confined to 26 only, and if there's not a character, we can ignore them, right? So basically, we at any point we know what are the starting points and where we should move. Say we found like over here we found A, so from A we know that there can be T only as a next character. If T is not there as a next character in our search results, fine, we know that there's no point moving ahead. Fine. So this is how this whole try is done. So if I just try to break it as a, let me erase this off. If I just try to draw this words array as a try, see how it will work. Fine. So first of all, we have, as I said, we have a root over here. Okay, let's not draw that whole array, but let's understand what else we have. Okay. So first of all, we have this root, and from this root, we will first we'll get O. That's our first node. That's a O. That's a O. Then we get A. Okay, then we get T, and then we get H. Fine. So that's a from root we got one path is that way. In case we find another word, that's bifurcating for T or bifurcating for A, will draw another root, like another path, and will form that case. But that's not a case we have over in this example. So what are the next things we will have? We'll have a P, right? So P, and then we have E, and then we have A, right? So that's the second word we have, and then we have E, right? So at any instance, as I say, okay, we always have max 26 characters to look for. That's known to us. Like mean can be less than that based on how many words are there, but the max there's 26 words characters we need to look for, right? There's another like R, A, then we have I, then we have N. Fine. So for each instance, we know if there's any characters that are overlapping on it. So that's how this try is working for us. Now, how is this helpful to us? Once we are looking for words to search in our character, like in our whole array, so we first know like which characters are we searching. First of all, we are searching for these characters. Okay. In case we made a search, say in this case we made a search like a search confirmation, there is a O is there, so we know that a O is there, so we need to look for this next character, this A. Now for O, we need to go on his right, we need to go on his bottom, we need to go on his left, and we need to go on his top to find an A. We found an A, right? We found an A over here. Now we need to go to the next character, that's T. What are you looking for? Is T is there on his right? Is T is there on his left? Is T is there on his bottom? Or is T is there on his top? Okay, we find another T on his bottom, right? So once we found a T, we'll look for the next character. That is what the next character is. It's H. So we'll again find a four-way search we'll do, or left, right, like bottom and top. Okay, and we'll find whether there's H or not. Now, if we look at the one of the cases, see one of the cases over here, it mentions that it shouldn't be in this way that the same letter cell, like the same letter cell may not be used more than once. Okay, so what that means, see, it was like O, A, T, A. Fine. If it was a word, so we shouldn't be looking to the back for a A. Okay, what it means is uh, like say if I just erase this off, say you will understand over here. It means uh, it simply means like from O we'll move to A, from A we move to T. Fine. So OAT is there, and then we got a A. So it shouldn't be that from T till the top we found a word. This shouldn't be the case. From T, since A is already visited in this word, so from T we should look for other places for this word. Fine. So how we can make a note of it? So whichever character we are finding a match to our try, we'll simply mark them and like remove that character as a hash or something else. So once a hash is found, that's why we're not looking forward. We'll move back. Fine. So that's the case. And after we found a word or we return back, so once we keep returning back, we'll replace this hash with the original character. We'll replace that. So that's one thing we should keep in mind. So how is this working? Okay, that let's think of the bigger picture. We'll first form this try node. Okay, all the try node will build this try node. Fine. Oh, first thing is we should define a try. We should define what try is. There isn't any definition for try. We should define that. Then we should build the try node based on each of the words given in a words array, right? Based on each of the words. Now, what further? The next thing we need to do is like we should start from like we should traverse from n square, like top to bottom, each of the nodes. Okay, and for each of the nodes, we'll make a DFS run to find out if there's any match from the words array and whether we can improve it or like whether we can find a word. So that's the word search we have. So I hope this is understandable how we're going. So first of all, in this given function, what we'll do, we'll try run a like n cross n loop, right? The m cross n loop of that, and for each of the character we'll traverse, and for each of the character we'll see if there's an DFS we can start or if we can find a word starting from that character. Based on that, we'll simply find out that. So what that means is like we'll keep a like try to find a match in our words array. If a words like the words array is giving a match for that character, then we'll move into that like this try, move in the depth of this try and find out the other words if we can. Okay, so that's the idea of this question, guys. So I hope you can understand how you can do that. So let's quickly go ahead and quickly write this code. Okay, so in that case you will understand how it's going ahead. So let's quickly write this code. So here you see that this is the code we have. Okay, so if you just look carefully, what we did, we first built our try class. This try class is like we have a try node that's pointing to the next node, and it's like 26 length. As I said, it could contain all the 26 characters. Fine, that's the 26 length, and then we find that if this string word, like whatever the current word we are moving ahead with, so that's a string word. Fine. Now further, we have another function that is a build try. Okay, so build try is like where we are building this whole tree that I saw you, like the try. So we have this words array. Okay, we're creating each of the like new node of this class as an object of this class, and what we're doing for each of the words, we simply divide in character by character. Like for each of the character in the words, particular word character, we simply put like whatever the index, we put that like p of next of I equal to null. So we just if that was null previously, we add a new node or we move to the p of I next. Okay, we just move forward in that word. The character, what it means is like, as I said, like first say O A T H is there, right? So we find O. So whatever with the integer of O, we find if it's like if it's not null, like if it's null, that means initially it should be null. So if it's null, we will add a new node, like new try node from that array. So it was like try node is there. So from that position, we add a new try node. Fine. And in that, we put like we traverse this current node to the next node. Fine. So this is the array where we are. Next node, we find A, and we find that this is the A we have, and next we move from A to the next. So if we already like what happens is if we find like build a path like this, next time when we are traversing the same path while building, so we already know that this is a word character that's the present. So that's a try node already present. So we'll move to the next character and then find a path out of it. Fine. So that happens. That's how it is. Okay. So I'll go through it once. I hope you can understand. This is not pretty complicated. So this is what we're doing. And then further, we have this build try node is there. Okay. And then if you just look carefully, we have this the main function like the find a words that was given to us. Now in that, see what we're doing. We are we have a list string race as a like the final resultant list which we are supposed to return. Okay, so this is the final result return. So next we build like in the try, we made a try object, that root, and in the root we have passed the whole words array. We passed it. Like build the try first. That's important. Now next, as I said, we traverse for the whole m cross n, like the m cross n this board given to us, and in that from each of the position we do a DFS search. Right, in the DFS search, so this is the DFS search we have over here. Okay, we have a DFS search over here. So what we did in that, we simply move like for what is the current character in the board, whatever it is. So we move ahead with it. So in this case, will be required when you are finding it the next time. So let's look further. So we searched that if a word is if it's a complete word or not. Okay, so we simply made a movement in our try node. Okay, so whatever the current character is, we made a movement. So if word dot not equal to null, that means we reached the end point, right? So this is the like the corner cases. Let's look at this further a bit later. Let's look at how we are traversing. Now, first thing is we made this current board position as hash. As I said, we will just replace it with hash. And then what we did, we moved it 4 directions. A DFS movement. We moved in 4 directions. If I greater than 0, I move to I minus 1. If j greater than 0, move to j minus 1. If I less than board dot length minus 1, then move to I plus 1. Or I less than board dot length board 0 dot length minus 1, move to j plus 1. Fine. And then after this recursive traversal, what we did, we when we returned back, we simply reiterated the original character to our board. Fine. Now, when we are moving into each of the iteration, so we need to see a few things. First of all, if our current board character is hash, that means we have come back to a position where we were previously in our current position. Fine. So that's a condition. So we've come back to something. So if it's hash, or if we find that p dot next, what is the p? P is a try. Okay. P dot next c minus a is null. That means the current character minus our current character position, that's the index, is null. That means there isn't any word following after that, right? So that means we should move ahead with our current character. That means if at any position we end up from after t, okay, after t we end up to a position of e, okay. So if I at this e there isn't any try node going ahead with that, right? So if there isn't a try node going ahead with that, there's no point. We will simply say return. There's no point going ahead after looking forward of t. We move to OAT, right? From t we can move e. From t we can move a. From t we can move h, as I said. But there's no point moving to e or this a, right? So we need to look for, and when you move to stop, that is this position from t, we'll find this equal to hash. We'll return. So that's we're just saving the time. Fine. Now, this is the maximum optimization. Like with this optimization, you can see this with thus we are going so fast. Okay. Now what's happened? We simply say like if p dot word is not null, like if our current word, we have a word, so like we find a word, so we keep a word in our moved it to our final answer. Okay, this is the rest. So we moved it to a final answer. That way, if we find it, okay, so if we find that this word at this position is not null, so I put that word in our array, and then we just make our word null. So that means we just moved it out of our try. Okay, so we just removed it out of our try. So that means there isn't any word further. Like once we have added a word, there won't be any word. So in case this oath is repeated 2 times, so that there won't be 2 word oath being added to, right? So we're just making it run. We're just removing it. Fine. This is how this DFS function works, right? And then we're simply returning our result. So if I just run this code and I'll understand how it works exactly. So if I just run this code, you'll say it's pretty fast, like 145 ms. But I guess this can be much faster as well. So anyways, that's not a big issue. Our code is working pretty fast in this case. So, this LeetCode issue is there. They are always confused about this turnaround time. Anyways, that doesn't matter. But if you look at this, like the time complexity of here, like first of all, it's an n squared time complexity. But with respect to n squared, that's not the end. Wait, it's n squared. But from each of the node, we are moving the DFS. Okay, this we're moving to 4 side. So it's more or less we are traversing. We're finding the word. So word length, like particular word length we find. That's the case we have, right? Because it will be broken up if we don't have a word in that. So there's no point moving further. So that basically means we have a n square multiplied by the word length. Okay, so that's the time complexity we have over here. So I hope I can make you understand how you can solve this question. And so thank you all for watching this video. If you have any doubts or any problems related to this video, like related to this question, make sure to comment them down. I'll be happy to help you out in the comments as well. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.